So last week we talked about values and ranking values, and we're going to be talking about demand this week. And demand has a lot to do with how you rank your values. And it also comes up a lot in talking about business, talking about understanding how things are going to change, how people are going to respond to prices. Demand is very, very important. So let's just recap what we've learned so far. Unfortunately, this other screen seems to be not working today. So we're going to be stuck on this. So if anybody has problems, say it. So we talked about the water, iPod, or iPhone paradox a couple weeks back. So why is the price of iPhones more expensive than water? Why are iPhones more expensive than water? Why are iPhones more expensive than water? They require more scarce resources is one of the answers we explored. Any other ideas? Why are iPhones more expensive than water? Yes?
Water is so abundant that the regular cost on a unit of water compared to a unit of iPhone is like next to nothing.
That's right. It's about the relative scarcity of the units involved. There are more bottles of water available than there are iPhones. And that the demand for iPhones is relatively greater than the demand for water. Okay? So, let's remember that when we value things, we are valuing specific units of that thing. And we talk about units, and we're going to be talking a lot about quantities. Let's remember, our quantities and units in economics, are they objective measurements or subjective measurements? Are they objective? Or are they subjective? They are subjective. Okay? Units, what counts as an iPhone for you, might count differently as an iPhone for me. You could take a jailbroken iPhone, and for you that's good enough. For me, I want a real deal, straight from the factory iPhone. For me, it has to be in a sealed box. You can buy it secondhand. Water might be different. I can only drink, Fiji water. I only drink Fiji water. The rest of you are okay with tap, like peasants. So not only are values subjective, what one person values, someone else might value differently. Some people like Apple products, some people like Samsung. But also the quantities involved are also subjective. The quantities are subjective, the values are subjective. But still, we can still graph this subjectivity this way. So we'll make a graph. On the vertical axis, this is going to be the ranking of n's. Okay? At the top will be your first rank, and I'm going to use Roman numerals for ranking of n's, because you remember, ranks are different than numbers. Ordinal numbers or ranks are different. You can't do the same things with them than you can with cardinal numbers. So just to avoid that confusion, I'm going to write these ranks, these ordinal numbers, as Roman numerals. So your first ranked thing, then your second ranked thing, your third ranked thing, and then your fourth ranked thing. Remember our Roman numerals? And then this would be the quantities that you like. Quantities. That's 1 unit. All right, 1, 2 units, 3 units, 4 units. If you have 1 unit of a good, you have 4 things that you can do with that. Good. If you have 1 unit, are you going to use that 1 unit to satisfy your highest ranked end, your most valuable end, or your least valuable end, or somewhere in the middle? Who's got a guess? Yes.
Would you use it for your highest strength? Because you only have a stairs and you use it for your highest strength.
So highest ranked end. Anyone disagree? Disagree? Yeah. If you are in the desert and you're thirsty and you're dirty and you've got your dog with you and you got to wash your dog as well, and you come across 1 glass of water, are you going to use that glass to first wash your feet, or are you going to first maybe have a sip? Right? When you have 1 unit of something, you always use that 1 unit to satisfy your most important end. So we would graph that with a little dot there. 1 unit, your most satisfied, your most valued end. What if now you got a 2nd unit? You got a 2nd unit. Which end now are you going to satisfy? You got a guess? You have a 2nd unit, yes. Your 2nd most important end. Right? Easy. So your 2nd most important end, and then goes down the list like this. Easy, right? Now here's a question. Can I draw a line through these dots? Who says no? That's a good number of you. Why not? In the back.
You can't have like half of a unit or something, or half of a quantity or something.
You could have half of a quantity of something. Well, like if you have a glass of water, you can have half of that, right? Who's got another reason why? Yes?
There's not like an intermediate area between your rankings.
Yeah. There's no such thing as a 1.5 ranked. You've got your first rank and then your 2nd rank. And then if you draw a line, it would imply that there's not only a 1.5 rank, but like 1 1 1/3, and then there's a 3.14, right? So when we're drawing your ranks like this, your ends ranked like this, don't draw a line. So we've got your ranked ends that way. And these are really subjective, right? But we don't live in a society where you're only bartering for things, going around deserts for water and stuff. We live in a market society where we've got lots of things available to us that are being sold at prices. And we can draw the relationship between prices and quantities similarly. So this is quantities, and this is going to be price. Your most valued end. Here we'll do 3, 4, 1, 2. Your most valued end. Are you going to pay a very high price to satisfy it, or a very low price to satisfy it? Something is really, really important for you to get. Are you likely to pay a high price for it or a low price for it? A high price. Put it up like that. What if now you get a 2nd unit of that thing? Are you going to pay a higher price, a lower price, or the same price as you did for the first thing? Lower price. And it goes like this. What's the difference between prices and ranked ends? You got a question in the back?
No, I was going to say you can control line through the price one.
Yeah.
You can have increments, whereas the other one is distributed.
Exactly. You can draw a line through this. Because we have a lot of different prices. This one could have been $10. You can have $9.50, $9.25. If you're paying in Bitcoin, you can pay up to 1/1,000,000th of a unit. Right? This relationship between price and we call this quantity demanded. Quantities demanded. The fact that you pay a lower price for more units, we call this the demand curve. And we call this a demand curve even though I've drawn it here as a line. Curve is just fancy mathematical jargon for it. Sort of line function. A straight line is also a curve. That's it. But the relationship that price is inversely related to quantity demanded, we call this the law of demand. The law of demand. Everybody's familiar with this terminology? Price, that's the proportionality sign. 1 over quantity demanded. Price is inversely related to the quantity demanded. That means as the price goes up, what's going to happen to quantity demanded? Price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. Easy. So, these quantities, we talked about them being subjective. What's also really important that the good in question, especially when we're ranking ends like this, the end that you're concerned about, the quantities, the units that are satisfying those ends, they have to be homogeneous. Homogeneous. Do not say homogeneous. Homogeneous. Okay? It's about a homogeneous stock of goods. Homogeneous. Let's say you're building a car, and you're building this car from scratch in your garage. It's going to need some wheels to get going. Is the unit, the base unit for the number of wheels you're going to buy, is it going to be 1, or is it going to be something else? You have a car with no wheels. How many wheels does a car need to run with? 4. So the base unit for the number of wheels for a car is 4. Right? If you're going to buy 3 wheels of something, that's not the same thing as buying 4 wheels. You'll price it differently. Does that make sense? You will price different goods differently. The slope of this curve, we call this let's not get to the slope yet. Let's talk about the percent change in price and quantity. So if we go from, let's go all the way up here to down there. Is that number going to be positive or negative? Big change in price, big change in quantity, it's a negative relationship. So we call that slope, that relationship, we call that elasticity. Elasticity of demand, or the price elasticity of demand. Price elasticity of demand. This equals to the percent change in quantity demanded over the percent change in price. price goes from, let's put some numbers on here. This is 10, this is 5. Price goes from 10 to 5, and quantity goes from 1 to 4. So what was the percent change in quantity there? You go from 1 to 4 is, what's the percent change? From 1 to 4. Percent change from 1 to 4. What's such a calculators? Percent change of 1 to 4. 25%? You're going from 100 units to 400 units. That's 25%. From 1 to 4 is, tell me this. Okay, let's do a little remedial math here. So percent change is the new minus the old over the old. Right? So the new is 4, old was 1 over 1. This is a 300%. Remember this? High school? No? Alright. So good thing we went over that. Because this is going to come up in your quizzes. Okay, so that's how you get percent change. So that was percent change in quantity. So now I'm talking about percent change in, quantity demanded. Now I'm talking about percent change in price. We went from 10 to 5. So our new is 5, our old is 10. Over 10, this is 50%. Right? Negative 50. So our elasticity then is 300% over negative 50%, which is 300 over 50, 6, negative 6. So that was for this big gap of price. If this gap was made smaller, what would happen to the elasticity? Would it get bigger or smaller? Let's do it this way. So we goes 10 to 5. Let's swap this 8 to 6. Right? So percent change in one in the negative. It will go from 2 to 3. Right? So we're going, the price is going down. So we're expanding our price. So our new is going to be 3 minus 2 over 2, which is 1 over 2, 50%. And the percent change in price is 6 minus 8 over 8. This is going to be minus 2 over 8, which is minus 2 over 8. How much? Minus 25%. So elasticity, 50% over minus 25%, which is negative 2. The bigger the gap, the bigger the elasticity. Up until you get to the very center of the curve. What should the elasticity be there? What should the elasticity be there? At if you get the gaps to be so small. If this gap is approaching 0, and this gap is approaching 0 but doesn't reach 0, what's going to be the final number? You guys gotta think a little harder. What? A very, very, very small number divided by another very, very, very small number. What's that number going to approach? 0? Let me try this one. Good thing I brought a lot of paper. So, call this, let's say 10 over 1,000, right? This is going to be 0.01. Let's say 10 over 100. This is going to be 0.1. Let's say 5 over 25. This is 0.5 over 25 to 5. Right? Let's say 3 over 15. 3 over 15. Speak up. 3 over 15. 1 over 5, 0.2. Say 4 over 8. 4 over 8 is 0.5. Say 2 over 3, 0.67. 1 over 1.5. You got a question? I can't hear you.
5 over 20.
5 over 20?
Yeah.
So I'm just trying to get you guys to think what's going to be 0.0001 over 0.0001. Oh, that's 3/4, right? This is 1. What's 0.0000000001 over 0.0000000001? 1. Right? Two tiny numbers divided by each other is going to be 1.
We did 5 over 25, and the last one you said 0.25, and it's 0.2.
Sure. Whatever. Moral of the story is two tiny numbers divided by each other is still going to be the same. And that's what happens when you get the elasticity to be very close to each other. Yes?
What does the negative, like I understand when the negative comes in, but what does it mean for the elasticity?
It just means which direction you're going up or down the curve, right? So it's not just the slope, because when our example was the price was getting lower, if the price was going up, it would have flipped around, right? So let's take an example. Let's see. Oh, well, actually, no. Here we go. So there are 3 concepts we talked about. So there is elastic, inelastic, and unit elastic. Right? Unit elastic means you have the same change in price and the same change in quantity. Right? So that's easy. That's what we just showed. Even if it's 0, almost 0 change in price will result in almost 0 change in quantity. That the limit is 1. Inelastic is related to the slope, right? Is this, so inelastic demand means that if the price changes the price is going to change a lot, but the demand is not going to change much. Inelastic demand means it's inelastic or unsensitive to change in price. So perfect inelasticity looks like a demand curve that's vertical. This will never happen. Okay? Some people say insulin. Is insulin perfectly inelastic? The demand for insulin, is that perfectly inelastic? Yes.
No, some people would choose not to get insulin and end up dying.
Yeah, if insulin costs $1 million a shot, people are going to find
Other ways.
other ways,
Or just die.
right? Maybe they'll just die. But people will find other ways of getting their insulin shot. Could be through black markets, could be something else. Elastic demand is just the opposite of that, is when demand is very responsive to changes in price. Perfect elasticity looks like this. So this is perfect inelasticity, inelastic, and this is elastic. Is there perfectly elastic demand, where any change in price going to be met with, what would that even mean? What perfectly elastic demand even mean? What do they even look like? Yes?
Is it when the price stays somewhat the same, but the demand for it goes up or down?
Perfect elasticity is if you change the price a little bit, you get infinite change in demand. Infinite change in demand. Sorry, quantity demand, right? So if the price goes up by 1 cent, you get 0 quantity demanded. If it goes down by 1 cent, you get all of the quantity demand. Yes?
What are your axes?
Sorry.
What are your axes?
The axes in economics, our axes 90% of the time are price and quantity. Yes?
Can you re-explain unit elastic?
Unit elastic
Yeah.
means that any percent change in price will be matched with the same percent change in quantity demanded. Any other questions? This is elasticity. I'm telling you right now, is the most confusing bit about this whole class, this whole course. If you can get through elasticity, everything else will be easy. Yes?
So are you saying elasticity, perfect elasticity, and perfect elasticity is impossible?
Yeah, so in each case, so for the whole price range, right? So here's what a real demand curve could look like. Price, quantity. A real demand curve could, for low quantities, be like this. And then it'll be like this, and then it'll come down like this, and then it'll go down like this, and then go down like that again. Something could look like this, right? So let's say this is 0 is here. That means that this you're looking to buy Smarties at the store, and at this point it's like $5, and this point is $10. You'll probably buy 0 anywhere between $5 and $10, right? But at $4.99, you'll buy 1. Between $4.99 and I don't know $2, you'll buy this many, up to let's say 9, and then from here you'll just buy way more, up to 10. It doesn't matter, you buy only so many. Yes?
By looking at a graph like that, are you able to just tell if something's elastic, inelastic, or inelastic?
Yeah, because it's the slope, right? So it's inelastic here, elastic here, inelastic here, and then roughly elastic there, to varying levels. Yes.
Do we ever graph unit elasticity?
Unit elasticity will just look like a dot, right? So it's on a curve. Somewhere on this curve, there's going to be unit elasticity because we're going towards this center, right? Because this is too complicated to draw, we simplify supply and demand curves with just a straight line, usually. It's a negative downward slope. We call this the demand curve. Let's talk about what changes demand. So demand is a function. So demand, do not confuse demand and quantity demand. Okay, so that's really important to get a takeaway from this. Quantity demanded is not the same as demand. Okay? Quantity demanded is not the same thing as demand. Quantity demanded refers to a specific or how many units at a given price. Demand is the general function. Demand refers to the whole curve, the whole graph. Quantity demand is that, this, that, right? So if the price goes down, the quantity demanded will change, will increase. But the demand is the same. What changes the demand is your own preferences. What changes demand is your own preferences. It'll cause, your preferences can cause a shift in the demand curve, right? It can go shift out, shift in. It can change the slope. That's all up to your preferences. Okay? If, like, how many people like celery? Probably, you like celery? How much do you like celery? Like, when was the last time you ate celery? Yeah. So, how many of you who don't like celery would then suddenly go out to buy celery if the news came out and said that celery cures cancer? Right? If celery cures cancer, probably most of you would go out and buy more celery than you would at current prices. Right? That would be an outward shift. At the same price, you're now willing to buy more units because your preferences have changed. If celery was then determined to actually cause cancer, it's worse than asbestos, you'll probably buy fewer units. The demand curve will shift leftward, inside. You'll buy fewer units at the same price. Yes?
So quantity demanded is the amount of goods.
Quiet, guys, please.
So quantity demanded is the amount of goods that buyers are willing to buy, but demand is their own desire.
Yes. So demand is a function of quantity demanded and price. Quantity demanded is just an output, just somewhere on that graph. Demand is a function of price and quantity demanded. And it changes by your own preferences. Do demand curves always slope downwards? Who says no? Do they always slope downwards? Who says they sometimes slope upwards? Yes? You've got an idea of when they would slope upwards?
No.
No? So, some people have thought about this. Where are my notes? Some people have thought about demand curves that are downward sloping at high prices, but upward sloping at low prices. Price. The idea here is that as the price increases for something and you have a low income, then you will buy more units of that thing by substituting from other more expensive things. So this is for staple goods typically. The story is for potatoes in Ireland. They said as the price of potatoes went up, people bought more potatoes and bought less meat, because meat was relatively more expensive, but potatoes were more plentiful but still more. You can get more out of potatoes than you could meat. So as the price of potatoes went up, you bought less meat and more potatoes. That's the argument. They call these Giffen goods, because the first guy to talk about this wasn't Giffen, but a guy who knew a guy named Giffen. It's a stupid story. But yes.
What about designer brands? The more expensive.
So we'll get to those as well. Let's actually jump to that now. So on the other end, we have goods that are downward sloping at low prices, but upward sloping at higher prices. So Louis Vuitton gets a lot of its value because it's so expensive. If they sold Louis Vuitton in Walmart, probably the demand curve would shift, would change a little bit, right? So we call these Veblen goods, after a guy named Veblen. Again, let's clarify, this is price. But let's remember the first graph we drew about ranked ends. Remember this guy? What would it mean for your ranked ends to go backwards? Does that even make sense? The answer is no. What's actually happening is that the same good at different prices, people perceive to be a different good. Louis Vuitton at Walmart is no longer Louis Vuitton. Right? You got a question? Prices can affect how you perceive a good. And with that, I guess I'll let you go. See you guys on Wednesday. Good luck to the Wednesday morning lab session for the parents.
Ja.